All right, so first off, we were reading from a file and we were writing to a file. So what do I need to include? F-stream. So we include F-stream. All right, and then what's the command to tell it to read from a file? ifstream. And then I give it whatever I want to call it, equivalent to cin. I'm going to call it read. Parenthesis. Quote. And then the name of the file, e:/integers dot text, comma, ios in. All right, and then at the same time, I think we decided we wanted to write our answers to a file. So I need almost the exact same command, except instead of ifstream, I use ofstream. And then again, I need to decide something that's like cout. What do I want to call it? Write, R-I-G-H-T or W-R-I-T-E? Whichever one I want.
It'll be right either way.
It'll be correct either way. Yes. e:/output.text, comma, ios, :out. All right, so there are the commands that will read from the file called integers.txt and write to the file called output.txt. All right, so once again, what this program was going to do, this program was going to read in a bunch of integers, and it was going to keep track of their product. So I think I need a variable to read in my integers, and then I think I need a variable called product. So what variable do we want to use just for reading in numbers? Well, I can't use read because I already used read as this command. Num1. All right, so int. Can't go wrong with num1. So that'll be the variable we use to read our data. And then we need a variable for product. In product, we saw last time, if you're going to multiply a bunch of stuff, you better initialize it at 1. All right, and so then what we did is we read the first number. And then we used a while loop to keep reading over and over and over again. So what was the command? Does anybody remember? While not read dot fail, and then you need another set of parentheses. So it'll try to read the first number. As long as it can, it'll come into this loop. All right, and then what do we want to have happen inside that loop? I want to multiply, so I want product times equals num1. And then? Now cin would be from the keyboard. We want to read in the next number. So we read num1. All right, so it'll read the first number. As long as it reads the first valid number, it will do the product for us, and then it will try to read the next number. And as long as it reads a valid number, it will do the product, and it will keep going until it can no longer read. All right, so then at the end, I think we wanted to cout the product is product. And then also write it. All right, so I would copy and paste this line. Again, why it does this the first time you copy and paste, I don't know, but it always seems to. And instead of C out, I will write it. All right, so I think that's pretty much where we were. Let's debug it and make sure it works. It says the product is 0. It's correct because I changed my file from last time. I put a 0 at the end. So I knew the answer had to be 0. It multiplies them all together, it gets 0. What's that?
Sneaky little bugger.
Sneaky little bugger. All right, so now let's change it. Let's put something in there that we know is bad data. So now I changed my data file to contain the number -2.1. So what's going to happen when I try to run? It's going to run 4. When it gets to this decimal point, what's going to happen? It's going to say that's not an integer, and it's going to crash right there. All right, so let's just try that. And it's going to end. And it says the answer is -60. Which is the correct answer if you look at the data file. It multiplied the first 4 numbers, and if you multiply those first 4 numbers, you do get -60. But that's not really what we wanted, is it? So what we want to do is we want to improve our code to say, you know, just because you failed to read doesn't necessarily tell me you had the right answer. So we want to put something in there that indicates, did it fail to read because it got to the end of the file, which would be a great thing. We hope it gets to the end of the file. Or did it fail to read because there was bad data? All right, so I'm going to come down here and I'm going to put an if. Read dot end of file. So what this does is it runs through. Eventually something failed. So this says if you got to the end of the file. What do we want it to do if it got to the end of the file? We want it to give us these answers right here, don't we? So if it gets to the end of the file, hey, we're really happy, we like that. So do that for us. So if it read all the data, end of file, great, we're happy. It prints the answer that it should print. What would you want it to do if it doesn't reach the end of the file? Tell you that it didn't reach the end of the file. That would be good. What would be better? All right, that's a different answer. We'll do that one in a few minutes. Correct. So you would definitely want it to tell you it read bad data. And again, imagine if your data file is really big. What might you want it to do? Tell you where it failed.
Character in position 30.
That would be ideal if we could tell it the character in position 30. Would it be good enough if we just told it what the character was, and then you could do a search for that character?
Well, if there's like 10,000 characters, it might
You could do Control F for find, and find the bad character, and then fix your data file. All right, so that's what we're going to do. We're going to tell it else, and now we're going to tell it to tell us what the bad character is. And so the way you do that is you do read dot clear. So what read dot clear tells it to do is go back one step. So it read, if you look at our data file, it read the 2, it read the 3, it read the 5, it read the -2, it read the decimal point, and that's what caused the error. And so right now the cursor is sitting right after the decimal point. So if I told it to read again, it would read the number 1. So read.clear tells it, go back to here and be ready to read that character over again. And then I want to read the decimal point. But decimal point is not a number. What kind of thing is it? It's a character, so I need a character variable. So I'm going to come back up here, and I'm going to make a character variable, char. I'll call it bad character. Don't hang out with the bad characters, that's right. So I told it to clear the read, which tells it step back and be ready to reread the same thing you just read. So now I'll tell it to read that. So read the bad character. And then I can do a cout. First bad character is bad character. So now what should happen? It should try to run this while loop till it gets to the decimal point. When it gets to the decimal, read will fail. So read without fail will no longer be true. It should say, I did not reach the end of file, so I'm going to come down here, and it should tell me the first bad character is, and then it should say a period.
So if you did read clear twice, you can go back twice.
That's a good question. I'm not sure. If we do read.clear twice, will it go back two blocks? I'm not sure. We can try that, and we'll see. Let's do this first and see if it works. All right, so it read. Eventually, it found that decimal point, and it said the first bad character is that decimal point. So now I could open my data file. I could do a Control F. I could search for a data point, and then I could decide, well, what was this supposed to be? Was this supposed to be the number 2.1, or was it supposed to be -2 and then a 1? And I can fix my data file. Okay. All right, so now let's try what you said. I don't know what it's going to do.
Does that work if you define it as a string and then it'll give you a whole number?
So if I do that twice, and it steps back twice, then it should read the bad character. It should tell me now the bad character is 2. So let's see if it will step back twice and give me the bad character is 2. Nope. So that you can only use that command once. You can only back step one spot, unfortunately. All right, so there's one solution at least. That's one way to clean up so that if you have bad data, it will find it. What's the bad thing about that?
You have 1,000 points sometimes.
There might be more than one.
And then if you have all those
You
points,
could just do nested as where you see.
Well, what this would do is this would allow me to run it. Let's say my data file looked like this, and it had an A here like it shouldn't, and it had a B over here. Unfortunately, this is going to read to here, and it's going to stop at that decimal point, and it's going to say, there's your first bad character. So I correct that, and then I run it again, and what's going to happen? It's going to get to this first bad character, and now it's going to say A is the first bad character. And then I would have to fix that one. And then what's it going to do? Then it's going to say, and so if you had a lot of errors in your data, you could be here a long time fixing one at a time. Kind of a pain in the neck. But it would work. And unless your data file was huge and it had lots of mistakes in it, it wouldn't be too bad. If your data file only had a couple mistakes, you'd be able to fix it pretty quickly. So what might be better than just finding the first bad data point? Finding all of them. All right. So how could we find all of them? With a while loop. So what do you mean with a while loop?
We can put the if-else statement, the second one there, read end of file one in a while.
Well, if it reads and it gets to the end of the file, I'm happy, life is good.
Couldn't you do while not read at the file?
So what I could do is with this else, read the bad character, and then do a loop here to keep going till it gets to the end, reading all the bad characters. All right, so what I would have to do here is add it in and say, so it's read the bad character, hasn't it?
Yeah.
So what do I want it to do now? I want it
Try to
to,
get to the end of the file.
so I want to read again, don't I? I want to read the next thing to see if the next thing is a good number. All right, so I read. What would I read? Num1. I want to test to see if the next thing is a valid number. So I read num1. And then I would do what? So we're going to want a while loop.
Not read it.
Well, not read dot end of file. Early bracket there, I guess. What do we want to have happen in that while loop?
To read the bad character.
Well, first I need to test to see if it's a bad character, don't I?
Okay, yeah.
So then I would need if read dot fail. So if it's a bad character, what do I want to have happen? Too many parentheses there.
You want it to read dot clear.
I want to read dot clear. I want it to read the bad character,
Yeah.
and then I want to see out
What the bad character
next bad character. Is bad character. Oops, I should put it in line. I don't know where that bracket came from. Put it bottom. All right, so now, once it reads one bad character, it should come into this while loop and try to read more of them, shouldn't it? All right, so let's go back to our data file. So now we should have 1, 2, 3 bad characters. Let's see if it will find them all. Nope. It's doing something interesting. What's it doing?
is waiting for it.
It seems like it's waiting for an input.
We don't have this here, though.
I don't have a CN. Something's not right. It's locked.
So you can't see it.
I can't see in anything. All right, so
Stop reading it. You don't have an else statement written out in the while loop. Let me get
this while loop.
it. Yeah.
Well, this one should run now until we get to the end of the file. It should run until we get to the end of the
We
file.
have it line between while and if. Read the other ones and using the two bad characters to see if mistake would be a statement or a while statement.
Say that again?
You have it run between the two bad characters, so you put a statement in between the while and the if. Then you can test to see if it's something different problem than the while statement versus the problem to be a school name.
After it read the above where you have highlighted well, it only reads that once, and then after that it stops. It doesn't read it. If it isn't the end of the file.
Oh, yeah. There's my mistake, isn't there? So it reads here. It read once.
And then since that's a good number, it will just go on.
That's a good number. It's not end of file. It goes into the if. It reads again when it sees a bad character. Yeah, I did a very bad thing. What did I do? I created an infinite while loop. I need within my while loop to tell it to read number 1 again. Oh yeah, it's crashed the mainframe again. First bad character is a decimal, next bad character is an A, next bad character is a B. So it is now reading all of our bad data. Alright, but as you can see, getting code to read bad data is kind of a pain in the neck, isn't it? But there's what you would do. Alright, well we're going to add some more stuff to this. Well, that's because we decided that if we got bad data, we weren't going to keep track of the product. We decided the person was going to have to go fix the data to make the product come out to be what it should be. Fix your data, dummy. Right. All right, so let's fix our data now. That's supposed to be a -2 right there. Take out the A, take out the B. All right. Let's run it again just to make sure it's still working. And it does. It says the product is 0, which it should. That was good. All right, so now let's add some more stuff.
So why can't you give data to the customer?
Because we used int.
So if that would change the flow of the
Correct. If this line right here were changed to float or to double, then decimal point would no longer be a bad character.
So right now, if we were just to type in float there and rerun it, would it still flag? It would still flag at 2.1.
It would not flag the 2.1 anymore. You want to try it? All right, I changed my data. I got to go back and change my data. So let's make this 2.1. So it will not flag that as a bad data value anymore because now it can read integers and it will read them all. Now it can read doubles, it can read decimals, and it will read them and it will tell me the answer is 0. Okay? So it's important to know what kind of variables you're using and what kind of data you're supposed to have. If your data is supposed to be integers, then your data better be integers and not decimals. All right, so I'm going to go back to ints here. All right, something else you might want to do. If you have a bunch of data, I do this a lot when I'm looking at test scores. A lot of times I want to know the highest test score and I want to know the lowest test score. So how could I search my data and find the highest score and find the lowest score? Okay, well I already have a nice while loop that's reading my data. Halfway there. Highest and the lowest.
So we can make two new variables, highest and lowest.
2 new variables. Int type.
Yeah.
Int.
And number 1 is not int.
Highest, lowest.
So you would read the first number, and then you would save that as highest and lowest.
You would read the first number. And the first number, when you've only read one number, it's both the highest one and it's the lowest one, isn't it? All right, so we're going to have highest equals num1.
Hi, Jess.
Hi, Jess.
Yes.
Well, that's over here.
It's a variable. You'd have to pick some number. Yeah.
Hey, I was consistent. I spelled it wrong twice.
Hey, you do the right thing.
As long as you're consistent, it's going to work.
Did you also say is equal to lowest and the technical line?
I believe you have to do that in two different lines. I don't think you can do it in one. One, num one. All right, so now it reads the first number. The first number is the highest. The first number is the lowest at the same time. Comes in here. As long as it's reading data, it does our product. But what else do we need to do?
What would you
It
want
has
to
to,
get after
yeah, it
the
has to be after reading.
Ah. So I want to.
Yeah, and then you want a statement.
Okay. So I want an if statement.
So if num1 is larger than the highest, then num1 is equal to highest.
Highest equals num1. Do it the other way. And then we need the exact same thing for lowest, don't we?
Yeah, if num1 is less than lowest.
Yes. No. Num1 is less than lowest.
Then lowest is equal to
Lowest equals num1. All right, and so then we would also want to come down here. If we read all the data and we got to the end of the file, then I want to see out stuff, don't I? All right, so I would see out the highest, the biggest data value is highest. I really don't like that second H today, do I? I should have. See out the smallest data value is lowest. Do I want those printing to my file also?
We're not going to check it. But yes.
Yeah, okay. Might as well, as long as we're writing to a file, we might as well write to the file. All right, let's try that. The product is 0. The biggest data value is 6. The smallest data value is -2. Oh, there it is. Scanning quickly, is the biggest number you see 6? Yep, and is the smallest one -2? Yep, all right, so that's working. What else might you want to do with your data? We might want to average it. All right, so that would be similar to multiplying it all together, except to average it, what would we have to do? We'd have to add them all together, and then we'd have to count how many there are. Okay, so let's do that. What's that?
the median.
Can you find the median? All right, how do you find median?
You have to take the count divided by 2 and find that number.
Right, you'd have to take
You have to
it,
read it again.
and you'd have to read it again. Yeah.
Let's do the median. Let's do everything.
When we get to arrays, we will learn how to take all this data and store it into one, instead of storing it into one variable, we'll actually store the whole list into an array, and then it will be very easy to find the median. Today, we have no easy way of finding the median.
So let's do the hard way.
Well, we're not ready for the hard way. We'll wait till we get to arrays. The way to really do that is arrays. All right, so we're going to find the average. All right, so I think I need more variables. If I'm going to find the average, what kind of variables do I need? I need a count.
And an average. I mean, you don't need an average. You can just calculate that.
count equals 0, and I need a sum equals 0. Okay. So it reads in the first number. We did our highest and our lowest. We come into the while loop. What do we need it to do? So we need to sum plus equals num1. Count plus plus. So we need to keep track of our sum, and then we need to say, hey, we had a valid data point, so we count with data. All right. That's pretty much all we need to find an average, isn't it? All right. So then we come down here. See out. The average of the data is sum divided by count. And I guess we're writing to our file too, so we'll do that.
Should we define sum as float, even though it's going to be an integer, so that when we divide it by count, it gives it that.
All right, I was hoping somebody would catch on to this. You're right. Sum and count are both what kind of variables? So when I divide two integers, what kind of answer is it going to give me? It's going to give me an integer answer. Is it really going to give me the average that I want? No. Two ways to fix it. Go back up top, make sum a double to begin with. Or just go double. Tell it to force sum to be a double right here. Then put float there. Whatever floats your boat. Bad computer science joke. All right, the average is 1.66667.
One integer.
Ooh, looks like it's 1 2/3. Is that correct?
Sure.
Well, I'd have to I'd have to check it and really see if that's correct, but I'm pretty sure it's correct. We'll live with it. What else might you want to do? Something you might want to do, the way that data is written, it's not particularly easy to read, is it? So what you might want to do is also print the data in a nice table where things line up. So you might want to have, like, I don't know, maybe 3 columns and have it print in 3 rather than like this one has 5 data points there, but only 1 there and 2 there. It might be nice to clean up the data, to print it to make it look nice. How do we do that?
Make it CL.
All right, but if I make it C out num1 every time I put one in, it's just going to list them across the screen, isn't it? I want to put it in 3 columns. Oh, we need IOMANIP. Okay.
Program we have a
Include IOMANIP. All right. So, when we read it, we want to print it also, don't we? So I'm only going to print it to the file for now. So I'm going to do write. If I want things to line up, I'll do a set width. Maybe 5, maybe, I don't know, 8. Num1. No. Yes, we can. It's just a pain in the neck. I don't want to do it. This is going to line up to the right. Why do you want it to the left?
Well, because if you want it in 3 columns, then you're going to want to hold 8 spaces, and the rest of the 8 characters so that they go to the next line. Just to do that like that, that's what I want to do. Real one.
All right, so what's this going to do right now if I run this?
Each one will be
It's going to run each one 8 characters. So let's run it and look at it. So I went to output.txt. So you can see it writes it, but it's not in columns, is it? So I need to tell it, after it prints the 3rd number, do an end line. How do I tell it, after you printed the 3rd number, do an end line? And then when count equals 6,
Count equals 3 times.
yeah, so I would need if count equals 3, or count equals 6, or count equals 9. And if my data file was really big, I'd have to keep going and going and going forever. There is a command.
Is it like count 1 is 3 equals 0?
Yes. So what do 3, 6, 9, 12 all have in common? They're multiples of 3, which is another way of saying if I divide them by 3, what's the remainder? 0. 6 divided by 3 is 2, remainder 0. There's a command for remainder, which is called modulus. So, we're going to put another little command right in here that says, if count modulus 3 equals 0. So what this symbol means is you take count and divide it by 3 and you look at the remainder. So for example, if count is 5, what would 5% 3 give you? It would give you, well, it's a nice remainder, it's 2, right? If I take 5 divided by 3, what's 5 divided by 3? 1 remainder 2. This thing, this percent symbol thing, always gives you the remainder. So count %3. If count is a number 5, 5 divided by 3 is 1 remainder 2. So this would be the number 2. What I want to have happen is, if count is, say, the number 12, was 12% 3? 4 remainder 0, so that would be 0, which means it's printed a 3rd spot. So if that equals 0, write end line. Every time that gets to a multiple of 3, it'll put a new line in. So it'll print 3 things. That's a multiple of 3, do an end line. It'll print 3 more things. Multiple of 3, do an end line. All right, so let's look at it and see if that worked. I don't know yet because I got to go to my output.txt. So there they are, nicely lined up. And I prefer that they be right justified, not left justified, because I think it would look weird if I had the 2 here and then I had the minus right below the 2. So I think right justified is better than left justified here. They line up in a better format. Questions on that? So that's a new little command there, that remainder command. That's one we haven't used before. That remainder command is very commonly used in situations like this, where you want to build a table and you want to have outputs of columns of 3 or columns of 4 or columns of 5, so on and so forth. So what would I have to change if I decided I wanted my output to be in columns of 4? I would just say count 4 equals 0. And now it will print it in columns of 4. Once you know how to do it once, it's easy to do it over and over again. So now it's in columns of 4. Ah, yeah, what's ooh about that?
Just add another end line.
Yeah, I should add another end line before I start printing the other stuff. because it wasn't an even multiple of 4. My data happened to be an even multiple of 3, so it did the one extra n line. So we might want to come back in here and
The CO.
right here.
That's another
And we don't really need it to be a cout, we need it to be in the file.
array.
So we'll put an extra n line in there just to be sure that that looks better. Okay. Any other interesting stuff we should do with this program? What's that? Ah, so his question is a great one. He would like to take the data, instead of just printing it the way it came in, he would like to print it from smallest to highest. You need some sort of sorting algorithm for that. And we could do it here, but what we would need to do with what we know right now is we would have to store every single one of these numbers into a different variable. So we would need, I don't even know how many different numbers there are. 12, 13, there's 15 numbers. So we would need to store the 15 numbers, save them, and then sort them. That would be a pain in the neck. In the not too distant future, we will start talking about arrays. So we will save all of this data into an array, and then there are techniques to use to sort arrays, and then you could print the array in order from smallest to biggest. So we will do that eventually, but not today. Or you could print it from biggest to smallest if you wanted to too.
From the highest equals number 1 and lowest equals number 1 means that you're saying the highest and lowest will both values fall under the term num1.
Well, what we're doing here, when this comes in, we read the very first number. So right now I've only read one number. I don't even know what the first number is. First number is 2. So when I read the number 2, right now that's the biggest number that I've read, and it's the smallest number that I've read, isn't it? Because I've only read one number. So that's what we're doing right there. We're reading the first number, and then we're saying, well, if we've read the first number, that's the biggest and it's the smallest. Later on, when we read the next number, when we read the second number, we look to see, is the second number bigger than what I've currently called highest? If it is, if the next number is bigger, then highest is now this new number that I've read in. And then we do the same thing here with lowest. We check to see the number that I read, is it smaller than what I already have saved as my lowest number? Other questions? All right, so other than sorting the data, which would be interesting, I think we've done pretty much everything I can think of that we should do with this data. I mean, there are other things we could do. I mean, we could find the standard deviation. I mean, there's a formula for that. I mean, there are other things we could find, but... And they would all work within this while loop right here. Anything you wanted to calculate pretty much within this while loop. All right, well, I think that's about enough for today.